simple harmonic motion. Do note, we are still going to do a lab report over this one. The deadlines will be in the document that I posted with all the new deadlines on all the labs and everything. So I'm gonna go in a little bit more of the theory because we have to do a lab report over it. Simple example of simple harmonic motion. A spring, lovely spring, right? We have our coiled spring with a mass attached and it's gonna move, right? Simple as example. Its force is equal to the spring constant times the amplitude. The spring constant will either be given to you or in this lab, we get to calculate it. And the amplitude is the distance in which it moves, right? So we have a couple different things. We can find our period, which is just 1 over frequency. Or from our period, we can also find the frequency, which is 1 over the period. It just depends on which one you're given or which one you need to find. For this lab, what we're gonna be doing is you're gonna find your frequency first, which will be the counts divided by time. And I'll give that all to you guys in the Word document, so don't worry. For part A, we're looking at a simple pendulum, right? So we're gonna have a string with length L with some type of mass on it. These will be wooden balls or a brass ball, and we'll give you those masses. You're gonna find your frequency from the counts, then you're gonna calculate your period, and from your period, given one of the equations in your lab manual, you can calculate gravity. And we all know what gravity is supposed to be, but be careful of units, and then you'll find percent differences. The second part will be like, hey, we have some springs. We'll be using 2 springs. It's a brass and a steel spring. First part is you're gonna be finding the spring constant for it. What is K? So we'll find the force, and then from the force, we will find the spring constant. And then the third part of the lab is like, well, we know how to find frequency counts, and from frequency counts, we know how to find the period, but we also know how to find the period using our other handy dandy equation. So you'll find the period, 2 different methods, and then determine the 2 different frequencies for these, and then do percent difference and see how far you are off. All in all, not too hard. Alrighty y'all, lab 9, procedure and experiment. So, simple harmonic motion. We're gonna do several different cases. First one with pendulums. So we have 2 different pendulums. We have our brass ball pendulum and our wooden ball pendulum. You'd basically be doing different trials. The first trials, yes, for the brass ball, say to use a length of 100 centimeters. However, for video purposes and to make it easier for everyone to see, we're just gonna do the 50 centimeters, well roughly, I'll explain that in a minute. First part of it would be to measure your length, to truly make sure, because I know your lab manual says 50 centimeters, but human error, and this would be a measurement error. So you measure it, record the actual number, and that would be your length. And then for amplitude, it says for the first one to pull it out 10 centimeters. So you just hold up a meter stick, pull it out 10 centimeters, and let it swing. Your partner, theoretically, would have a stopwatch and you would do 10 full counts. A full count would be 1, 2, 3. So you would do 10 of those and record how long it would take you to do that. You would take those counts and then divide it by the time it took you, and that would be your frequency. And then from that, you find your period, and from your period, you can find the gravity constant. And then you would do the same thing with your wooden ball, 10 full counts, so 1, 2, 3. See how long it would take you to do it, as your partner stop watching. Divide the counts by the time, and that's your frequency, and so on and so forth. And then you would do the brass ball at 2 different lengths, or 2 additional different lengths, which is 100 centimeters, with different amplitudes. So not only the 10 centimeters, but also 20 centimeters, and see how much longer it takes. Because in your discussion and also in your graph section, you're gonna be able to do graphs correlating how the period and the amplitude are correlated, or the period and length are correlated, and all these different correlations. But we'll discuss that in your data section and show you figures on how those are supposed to look. Alrighty, the second part of this lab is to calculate the spring constants for both of the springs. We have a brass steel and we have a steel spring. So what you first do is you hook on your hanger, it's 50 grams. And then we measure the length of your spring from the bottom here to the top up here. Then you add 500 grams, so that'll be 0.5 kilograms. Figure out how far down it goes. So measure once again, and that will be your length final. From your displacement and your mass, you can calculate your restoring force, and then from your restoring force, calculate the spring constant. It's pretty easy, but you'll need it for the next part, and we would do it again for the brass spring. I would show you, but it's really loose is the key word to say it, so it's gonna drop down really far past the video camera screen. But yep, see, too far down. So I'll do all the demonstrations with the steel one for the next one too. Similar to the first part, you put your little hanger on, but this time you have to include the hanger mass. It's very key. You add your 500 grams, and then you pull it down in amplitude, the different amplitudes. So you find the bottom, pull it down 5 centimeters, and then pull it down, and then let it bounce. Now, as it goes up and down, that's one count. And once again, we're doing 10 counts, recording the time to find the frequency. So we'll do 10 counts, full oscillations, record it, and then find your frequency. And then from your frequency, we can do the handy dandy period, which is 1 over frequency. So we can calculate the period using equation 4 from the lab manual, using the spring constant that we found in part B. So the second part of this will be find your frequency or your period from your counts, and then find your frequency using your spring constant equation, which is equation 4, and compare the two values. How do they differ? Alrighty, that's all of it for this lab.